Hi, this is Jerry KM4ZKB Zulu Kilo Bravo. In this video we're going to be upgrading our remote antenna switch. The remote antenna switch was created a few months back and it's been outside since then. And there were some suggestions made and some things I had thought about as well about upgrading the switch. Well, we're gonna attempt to do that in this video. In this video, we're going to be setting up a power off default. And we can either do that to a specific antenna or we can do it to a dummy load. Not 100% decided on that yet, but the other thing we're going to do is a lot of these longer wires we're going to replace with Coax. And I'm going to use RG-316 Coax. And also, in order to facilitate that, I'm going to have to put in a ground bar or a bus bar to terminate the shields of the Coax 2 near the relays. So I'm going to be mounting that somewhere in this area. The other ends of the Coax, the shields on the Coax, will either be connected to this bus or a similar bus or to the shield side of the SO239 connectors. And as we know, this entire aluminum panel here is at RF ground. So we're going to be going through that. It's going to be a good upgrade and I think you'll like it. It's going to, I think, look a lot better instead of all this spaghetti. But it may be a little harder to follow what's going where. But let's get into it now. And I'm going to do a lot of this off camera, but then explain what I've done, because it's going to take a long time, as you might expect. But we're going to leave some of these wires, these yellow wires here. I'll probably shorten them up a little bit, but for no longer than they're going to be once I get through, I really don't think it's going to justify using shielded Coax. But these longer ones, the blue ones and the red ones, and this particular yellow one here, I'll probably use Coax on all of those. After I do some work, I'll be back and explain what I've done, and I think I'll take it one color wire at a time, so it'll be a little easier to follow. So let's get into it. Well, this has gone a lot further than my original thoughts as what I was going to do. But as you can see here now, the remote switch looks quite different. And to me, it's not as colorful as it was, but I think it's going to be better RF-wise as far as possibility of losing some signal strength. Also, we've got a safety feature built in now that if for some reason you lose power or forget to turn the power on for the remote switch, antenna port 1 here is defaulting to be on when there's no power. You can connect a dummy load here or connect a multi-band antenna, your choice. I plan to use it with a default antenna here. That's one way you can do it. You know, if you've got a multi-band antenna, you don't even have to turn on the power if you put it here on position 1. With this new safety feature, I did have to change the wiring a little bit, because we want antenna port 1 to be energized when there is no power on relay 1. So in order to do that, I had to move the connector for the RF input to the relay to the normally closed contact, which is the one in the middle. The normally open contact is used for all the other 4 relays, which is on the normally open contact. And I also had to make one change here in the control box. You notice this pin is currently unplugged. It used to be here and it controlled relay 1. Well, now relay 1 will be energized anytime the power is turned on. And what does that do? It disconnects the RF from going to port 1. So anytime the power is turned on here, it will energize this relay because I've got it running from the same connector over to the positive bus. So right now, with the power off, and this relay is in the normally closed position. And we can see that here on the NanoVNA because our log mag, which is measuring our insertion loss, is way up here, and we've got virtually no insertion loss. It's reading negative 1.64 milli dB. That's extremely low. Milli dB, 0.00164 dB. So virtually no insertion loss here between 1 and 30 megahertz. There is virtually no difference all the way across there. So right now we've got our port 1 from the NanoVNA connected to the input port to the remote switch. Okay, right now with the power off, it's going from the input to port 1 on the remote antenna switch. You can see we've got a little climb in the SWR depending on the frequency, but there right at 30 megahertz, we've got SWR of 1.36, and it drops as you go lower in frequency all the way down to 1 megahertz. We've got 1.012. So it does introduce a little SWR, and I believe if you go back and watch the original video, we had similar readings there. So the Coax did not change that. My take on that, it's the reactance of these just going through the relays here. You know, I've taken out, you can see here, I've taken out one of the terminal strips that used to be down here, and I created these ground buses, or common bus, whatever you want to call them here, and they're fastened to the back plane with stainless steel screws, and then I soldered all of the shields to these buses. So with the stainless steel, even though we've got copper on aluminum on this back plate, with the stainless steel hardware, that should eliminate the possibility of reacting metals where they start corroding, but the stainless steel should take care of that. But we had similar readings on the original version of this. But so you get a little SWR in a test scenario, and I believe we found in the original video that when you get a real antenna on here, you don't see hardly any change at all. And we can test a few of these. I've got 3 different antennas that I can put on this in a real world and do a test, and we'll get to that here later. But the only real change I did was moving to the RF input to the normally closed input on the relay, where, you know, the other 4 remained as they were on the normally open relay. And we've got power, that anytime power is turned on, it energizes relay 1, and since we're on the normally closed, if you energize that relay, it selects the normally open and disconnects the normally closed. So that disconnects that antenna, and of course you never want to switch while you're transmitting. You don't want to do that. So after you do that, you need to select one of the other 4 antennas. So here, let's energize the power supply, and you should be able to see here the traces on here have changed significantly. Let me get this light a little bit more out of the way here, get the glare off of the screen. You can see now that our SWR is way up here because we've got an open circuit now. There's nothing connecting these 2 together. There's nothing connecting from the input to port 1 anymore, since we've energized that relay, which disconnects. So we've got no connectivity here. So this is what you're seeing here. So let's move from port 1 to port 2. Okay. Well, you know, nothing changed. Why? Because we haven't selected antenna 2 yet, or port 2. All right, it takes it just a second to rescan. Sometimes these NanoVNAs don't act right. And what am I seeing here? Have I not got connectivity? All right, let me do a little diagnosing here and see why the log mag is up there. I'm trying to think, and I can't see anything, so I'm going to need to do some continuity testing, and I'll be back. Okay, had a little glitch. Not sure exactly what happened, but the log mag started going all the way up to the top line, which is in positive territory, because right now it's basically on the 0 line. I had just calibrated the NanoVNA prior to starting the video here, but I went back through the calibration again, and it seems to be okay, so I'm not sure exactly what that was. But now we've got the power on. As you can see, the LED is illuminated here, and we're in position 2. So we've got antenna 2 selected, and we've got the NanoVNA port 2 connected to the antenna 2 position. And we got basically the same readings as we did on port 1, which is what we hope to see on all of them. We're still on the 1 to 30 megahertz scan, so that's great. Let's go ahead and go to antenna port 3, and I'll switch it, and you can see now port 2 is disconnected. So we'll move the connector from antenna port 2 to antenna port 3. And we're back to virtually the same readings on all of them here. So that's working as it should. Go ahead and disconnect from antenna port 3 to antenna port 4. And you know, it's still open because I haven't changed the switch yet. So let's change a switch. Give it a second to rescan, and boom, there it is. Still virtually no insertion loss. We got negative 547 milli-dBs at 30 megahertz or 29.7 megahertz. If we take it down to 1 megahertz, we got negative 28.7 milli-dBs, which again is virtually no insertion loss. You know, everything here, in my opinion, is a lot cleaner. We've got the Coax, so you know, if you're wanting to run power, this should handle it a lot better. You should have fewer spurious emissions, or whatever you want to call it, coming from this, because it's a much cleaner installation, and all the coax is grounded on each end, so we shouldn't be radiating anything between the relays and the antenna connectors. So that's the way it works. We may as well test the next port. Again, this is disconnected now. Let's move from port 4 to port 5. And we should see basically the same readings, which we do. If there's any change, it's minuscule. So I think what we'll do now is actually connect the radio and some antennas on here and see what some real world readings look like. So after I get it all connected up, I'll be right back and we'll see what it does. Okay, I think we've got it all hooked up and ready to go now. Got the radio connected here, and I put a dummy load on position 1, which is the default with the power off. So we should be connected into the dummy load at the minute, and you can hear the radio in the background possibly. I've got it on low volume, but just ambient noise, or whatever you want to call it, background noise is all we're hearing there. Let's we're at full power, somewhere around 100 watts, and I've got the tuner in bypass mode, so the tuner should not be impacting anything. So let's key it up and see what it does with power off, defaulting to output 1. And I need to put it in the RTTY mode. It ain't going to do anything in sideband. So let's see what it does now. Okay, we're getting 103 watts, 102 watts at 1.01 SWR. So that seems to be doing very well there. So if we turn on the power now, it has disconnected the dummy load from this port here, and we need to select an antenna. And what I've got here on position 2 is my 40 meter delta loop, which should work fine here for this frequency. So let's put it into RTTY mode and see what it does to antenna 2. And we're reading about the same. It's 100 watts basically and 1.06 SWR. So it's working. Let's go to the second antenna here, which is going out to where the antenna farm would normally be. What I've got connected out there is a ZS6 BKW. I just put a double female barrel connector connect the two coaxes together where the switch would normally be. So let's see what it does when we select it. Not quite as much noise there. It's about the same, I guess. So we're now connected to antenna port 3, and let's see what it does there. It don't like the tune on that one. I don't know if something is on the antenna. I haven't checked the antenna, so don't know there. So let's tell it to tune here. I'll take it out of bypass mode and tell it to tune. And let's see, I'm in RTTY, so okay, it tuned it up, and it's putting out 94 watts, and it's tuned to 99% efficiency. So that's just differences in antennas. And like I said, I haven't physically checked the antenna. Don't know if anything's wrong with it or not. So let's go to the next antenna, and this is my off-center fed dipole. And let's just see here. We'll bypass the tuner again and see what it does. It ought to tune up better. Am I missing something? Oh, I'm in the sideband. All right, so there we go. Okay, it needs a little tune also. It's only outputting 80 watts. So let's have it tune. And it's about the same. And again, we've had storms and stuff, and I haven't checked my antennas, but the main thing is the switch is working, and I'm sure it would do the same on antenna position 5. Do you like the new setup? You know, I took out this terminal strip, barrier strip, terminal block, whatever you want to call it. I took that out. It used to be right here. I think this is much cleaner. I think the connections are better. We still have our surge protectors in there on each antenna, and we've got default protection, because now if we lose power accidentally, it's gonna, in this configuration, it'll go to my dummy load. You can put a dummy load on this out in your box, or if you prefer, you can put a dummy load and mount it directly here and run the coax to the dummy load rather than to antenna position 1. Your choice. Whatever you think works better for you. I think in normal configuration, once I get it out there, I will put the ZS6BKW here. My delta loop and the OCF dipole I use on a different switch because they're on the opposite sides of the house. You know, I can't get them both, all 4 of them, from the same location with this. And if you remember, Lord willing, we're hoping to move here in the next couple of months. We're still making arrangements for that. A lot of things going on, and that's one of the reasons I'm not putting out videos as often right now. Well, I hope this has been somewhat entertaining, educational maybe. I don't know. If you haven't seen the first series of videos on building this, I'll put a link. I'll put a link to the playlist up here, and it will also be in the description for those of you that are watching on a TV, where you can click on that to see the playlist of where the original build was here. I did not record doing all this because it took some time. I mean, probably a total of 4 hours to make these changes where I took this out, replaced all the red and blue wires with coax, and I actually eliminated the red wires altogether. That's another thing that's different. Now, when an antenna is unselected, it's just disconnected. In the previous setup, it was shorted to ground. And I questioned whether that was necessary or not, and whether it could cause some issues or benefits, depending on positioning of the antennas that are connected to the switch here. Because it's, you know, if you're if you got an antenna and based on its position, if you short it to ground, how does that affect your radiating pattern on the other antennas? You know, if they're both resonant on the same frequencies and you're using one that is resonant and you got another one shorted to ground, how does that affect your radiating pattern? Not sure about that. So leave me a comment whether you think when an antenna is not in use, not selected, does it need to be shorted to ground? Give me your thoughts on that. But anyway, they're not anymore in this configuration. If they need to be, I can easily add them back. Let me know. But hopefully you've enjoyed it, and thanks for watching. You know what to do. Appreciate you being out there. Hope everybody's 2026 has started off well. Hopefully we'll get back into the regular swing of things and get videos out on a more regular basis here in a few weeks and get back on a regular schedule. Thanks for being out there and watching. Hope you have a blessed day.